It's time for a cure. Time is everything. I have FSH Muscular Dystrophy. It's a slow and unstoppable degeneration of my muscles. It makes it impossible to do so many simple things others just take for granted. FSHD is the most prevalent form of muscular dystrophy. It can be passed on from parent to child, or it could just be spontaneous. No one is immune. It's not only had a devastating effect on me, but on my family's life as well.
It breaks my heart to see my husband suffer. Everyday walking becomes more and more difficult and dangerous. He's fallen several times already.
We hope for the day our daddy will be able to run and play with us, and to pick me up in his arms.
But after decades of hope and your generous contributions, that day may be closer than you think. We are, at last, beyond just hope.
Yes, the good news is that the decades of research, generously funded by your contributions, have produced amazing breakthroughs.
We are really, really close now. It's time for a cure.
Hi, I'm Max Adler, and I play Dave Karofsky on the TV series Glee. Growing up, I saw firsthand how devastating FSH can be. My mother and my grandmother both had it. Without a cure, my family and I watched the damaging physical, mental, and emotional toll this disease took on those we dearly loved. I stood by helplessly as they were robbed of their ability to do the simplest, everyday tasks.
We are finally on the verge of an effective therapy and even a reversal of the devastating muscle degeneration, so that Jeff and countless others can at last have a normal life.
The time is now. I know we're almost there. Soon, with your continued generosity, I won't be afraid of falling when I try and cross the street, and I'll be able to pick up my beautiful children and dance with my lovely wife, Beth, whose unfailing support gives me courage.
I'm very happy my wife Takako and I were asked to participate in this update. We are truly optimistic about our progress and the very significant strides made by FSHD researchers around the world. This past year, with help from the FSH Society, an international consortium discovered a genetic cause of FSHD2. This has been a major breakthrough in the field.
Together, as part of the larger collaborative effort, funded in part by the FSH Society, we found evidence for modifiers of FSHD, suggesting we may be able to slow down or stop the disease progression.
These encouraging new breakthroughs provide us more energy, enthusiasm, and excitement for a final push to a cure.
More than 500,000 people around the world live with FSH muscular dystrophy. Thanks to your generosity, the FSH Society is funding research leading to treatments and a cure. The FSH Society has earned its 5th consecutive Charity Navigator 4-Star Award and has been named one of America's 10 charities worth watching. The award praises our effectiveness and exceptional performance in channeling such a high percentage of your donations into cutting-edge research.
We could really use your help, now more than ever.
With your generous help and the dedication of the many researchers worldwide, the crippling effects of FSHD will be gone forever.
Please don't stop now. Now is the time. The time for all of us to make the final push for a cure.
Thanks for helping to make a cure possible. Please help my daddy.
So hi everyone, my name's Jeff Statlin. So I'm a neurologist at the University of Kansas. I have specialty training in experimental therapeutics and neuromuscular diseases, which is a mouthful, but basically just means that I do clinical studies in people. And so what I want to talk to you about today is clinical trial readiness, and I really want to talk about some projects that are going on right now, including an FSHD clinical trial research network that we've put together and some studies that are running on this. But nothing that I do is done in isolation. It's all really a collaboration with lots of people, and you can see a number of the other people that I work with listed on this first slide, as well as some of our sponsors. And without them, we couldn't do anything, including the FSH Society, the Friends of FSH Research, and more recently, the Muscular Dystrophy Association. So why now? Advances in our understanding of FSHD have identified potential targets for therapy, as you just heard in the last talk. So right here, I'm showing you a picture. This is a cartoon illustration of the molecular pathway in FSHD, and I'm going to spare you the details in my talk because you're going to hear a lot about this in the next couple talks. But what I want to point out are those red arrows, and each of those represents pieces of this pathway that we could potentially be approaching with drugs, and the chemistry to make these kinds of drugs is in existence now. And so research and companies are developing molecularly targeted therapies today. In addition, we have companies that are also moving forward with therapies which may benefit FSHD, but are not molecularly targeted. For example, Acceleron has a trial going on right now in FSHD of a drug that's supposed to increase muscle volume and potentially function as well. Hand in hand with the work in the lab comes the work that we as a clinical research community need to do to get ready for clinical trials. So it's a process of innovation and collaboration. We need people from all over the world doing different things, thinking outside the box, thinking of new ways to measure FSHD and new avenues for treatments. But ultimately, we need these people to then come together so we can test these ideas in larger groups of people. If we can agree on approaches, we can accelerate drug development, and we can take lessons from some of the other diseases like Duchenne muscular dystrophy or spinal muscular atrophy, where when they were able to come together as a research community, they were able to answer lingering questions about how to measure changes in the setting of clinical trials and really accelerate therapeutic development. So what is a clinical trial research network? On its simplest level, this is a group of academic or private research centers who agree to work together to accomplish common goals, to create more efficient processes for running clinical studies. There's power in numbers. By agreeing to pool our resources, we can answer lingering questions about the natural history or our outcome measure development for FSHD. We can ensure findings at one center can be replicated at multiple sites. And this is really important for a rare disease where we're likely talking about clinical trials that will require multiple centers across the country or the world. And by including multiple sites, the findings are more likely to represent a broader FSHD community. So this is a map of the country showing our current state of the FSHD Clinical Trial Research Network. You can see we have 7 active centers, which are the gold stars, distributed across the United States. It really started in 2016, has been growing quickly. We had funding from the FSH Society and private philanthropy initially, and now, of course, we have funding from Friends of FSH Research and the Muscular Dystrophy Association. The overarching goal is to hasten therapeutic development for FSHD, and you can see those gray stars on there. These are sites that are coming to me, telling me they're interested in being part of the network, and so the network is growing. By the end of the year, I suspect we'll have 10 sites that are active. This is a cartoon illustration just demonstrating on the left the start of forming a research network, and on the right this idea of trial readiness. And this is just to show you how the aims of a network are supposed to help get us from one point to the other. The first aim is not all that exciting. It's to streamline infrastructure. I am lucky enough to spend a lot of my time thinking about things like infrastructure and administration. One of the things that we're doing is we're trying to streamline the regulatory oversight. For every study we do in people, it requires an ethical review at an institution. And the old way of doing this was each institution would do their own review and make changes to the protocol you were going to do, and then they would bounce back and forth between all your sites, and each one would keep re-reviewing it, and it would take forever. Our solution to this was to create a central IRB, and everyone would just agree to abide by their findings. We also have implemented central coordination in data management. This is important because you want to make sure that people are collecting the same kinds of data in the same ways and making sure those data sets are complete. Another important aspect of this is training the key personnel, the coordinators and evaluators, so they're doing things in the same way. Our second aim of the network was to include the voice of all people who have a stake in what's going on in FSHD therapeutic development. An example of this is our external advisory board that has a clinical trialist, a representative from a drug company, they have a representative from an FSHD advocacy group, as well as a patient representative. We also include patient voices in our patient advisory panels that we form, and we did one of these when we were starting up our current clinical trial preparedness study to give us some important feedback about how we were doing things, but we can also ask questions about how to recruit people, how to keep them in studies once they're started, as well as how do we get the word out about what we did in the study after it's done. And we also have a mandate to be working with these companies that are developing the therapeutics. The third aim I'm going to get to on the next slide, which is to actually run studies. This is what the network's for. This is to fill in the gaps that we have and the information that we need so we can run high quality and efficient clinical trials. And once we have all these pieces in place, now we can use this network to train our next generation of FSHD researchers. And this just isn't clinicians like me. It can be basic scientists, statisticians, epidemiologists. All of these people have a role in running high-quality clinical trials. And we have a commitment to make the large clinical data sets that we'll be collecting available to anyone with an interest in developing therapies for FSHD. So these are the studies that are currently active on our network. We're lucky enough to have got funding from the National Institutes of Neurological Disorders and Stroke to run a really large study, perhaps the largest ever natural history study of FSHD in the United States. We'll have 160 individuals who will be followed for 18 to 24 months. Our primary goals for this study are to refine our trial strategies. This includes how we think about creating inclusion criteria, whether there's things that we see the first time we see someone at a visit that can predict what's going to happen over the next 6 months to 1 year. This gives us a chance to validate new outcome measures, a functional composite measure for FSHD that I'll talk about in the next couple slides, biomarkers like electrical impedance myography, and a patient-reported measure of patient-reported health impact. And we've been lucky enough to have 2 European sites agree to collaborate with us, Nijmegen in the Netherlands and Milan in Italy. So now it's truly an international study, and a special thanks goes out to the Friends of FSH Research for making this possible. We're recruiting now, and so if you're interested or want to participate, you can call my project manager, Kylie Higgs, who's very nice, and she'll get back to you and let you know about how to do that. Like I said, we had a mandate to reach out to industry, and Fulcrum Therapeutics is in the process of developing a potential therapy for FSHD, but they came to us and said, you know, we think that we need a better way to measure upper extremity function, and we want you to take this device. It's using a 3D camera called the Kinect. If any of you have an Xbox or a child who used an Xbox that had the motion camera, you've seen one of these before. But in this case, they use it to measure how much volume of space you can reach in. And so we've added this to our study. And there's additional studies that are in the process of starting up and will likely be happening within the next year. I wanted to give you one example of developing an outcome measure to show you sort of how this works within a network like ours. And I was going to use this FSHD functional motor composite Developing outcome measures is an iterative process. What I mean by this is it usually takes several cycles of development and testing. The first step, though, is like homework. It's what do we know about FSHD? I go back and look in the literature. We look at expert opinion, prior studies, genetics, molecular pathology, MRI anatomy, but it also has to include the patient experience. This chart I'm showing you here is from a survey that was run by Acceleron and the FSH Society, where they asked people to rank a number of different symptom categories as to whether or not they had them and how impactful they were on their lives. The dark green are the highest percentage, and you can see the three most prevalent and impactful symptom categories had to do with weakness in the legs, in the arms or shoulder, or in the core or abdomen. So if we're thinking of a functional composite measure, for FSHD, it's important that we're capturing those regions. And you can see here an illustration of how we did this. We just created a table with each of these different regions of the body. And then I figured, well, physicians aren't really the best people to pick what will go into this measure. So we asked our physical therapists who do these measurements all the time. And they helped us pick a number of measures that are already fairly well validated in the setting of muscular dystrophies, and we put them together to form this total score, which gives you 0 to 72. But like I said, outcome measure development is an iterative process. So then we had a number of other steps. We went ahead and tested it in a small group of people at 2 sites to make sure that it was a reliable thing to be testing and that it correlated to other measures that we thought were important for FSHD. And then we went back and we asked researchers and people with FSHD how they felt about the measure so we could revise it. We used this clinical trial research network to do this, and we did this by doing a focus group. And you can see we had 35 individuals from all across the United States. And we asked them about each specific element of this functional composite. Some of you may have participated in these phone calls. And we actually took that feedback and used it at our investigator meeting, and the evaluators changed how they did things based on the feedback that we got from individuals. And we were able to also incorporate recommendations regarding what might be missing into the design of our current study. But we still have a lot to do. We need to understand how things like this functional composite change over time. And we need to know how genetics or baseline status affect progression using these types of instruments. We need to know how large a change in this would be meaningful to people with FSHD, and that's really what the CTRN can help us get an answer for. So in summary, clinical trial preparedness, it's really a process and a collaboration. There are many people involved. Understanding the natural history and how we measure things can help us gain approval for new drugs and ensure we're not discarding a treatment which might be beneficial, or the inverse, approving a treatment that's not really going to work. And having this network gets our sites ready to participate in these clinical trials. It creates a national group of trained coordinators and evaluators, and it can help individual investigators or small companies take their drugs into clinical trials. And so I just wanted to conclude by talking about different ways that people can actually participate, and these slides will be made available if you can't copy down this information quickly. You can contact us directly through our project manager. You can find studies by looking on clinicaltrials.gov. If you've ever seen me in clinic, you know one portion of what I do is I sit down and show people how to do this. Here I've entered the term FSHD, and if you search, you pull up studies. This is an example of our study that we're running now. You can find our FSHD Clinical Trial Research Network. It's hosted on the KU website. It is a site in construction, so if you've ever driven somewhere and seen that this is under construction, so is this website, but you can still contact us through it. You can go to the FSHD Society website and search for us, or you can register, as you've heard before, with the National Registry of FSHD Patients and Family Members. So I want to thank you very much, but I think I'm not quite done because I think we have a real treat now, because we have a couple individuals who's agreed to come up here and share some of their experiences with participating in clinical trials and what it was like for them. We have Carden Wyckoff and Jim Fox, and I want to thank you both for coming up and doing this. June, do we have some microphones? Okay. All right. And I can, do you want me to, yeah, I can just take this one off. Okay. Well, I thought what I'd do is, why don't I just give a couple questions, and then I'll let you guys talk, and you can give me your feedback, and we'll see if people have questions, and you can feel free to answer. But I thought to maybe start out, you could tell us a little bit about your experience of taking part in studies, and maybe give us a sense for why you wanted to do it, how you picked the kinds of studies that you did, what the experience was like for you, if there were parts that could have been better or parts that went really well, and maybe you could even tell us a little bit about what you learned from the experience, or whether you learned the results of the study you participated in. Yeah, and either one.
All right, I'll take it away. Hi, my name is Carden Wyckoff. I'm from Atlanta, Georgia. So I've participated in about 3 clinical studies, and so that's different from a clinical drug trial. So with the clinical studies, they usually are just 1 day, sometimes they're 2 days, and you go to the location, and in the studies that I did a full MRI body scan, and that was 4 hours long, sitting in an MRI machine. And I actually didn't find out what the results were. I had to stalk the researchers and figure it out. Mainly because sometimes it takes a couple of years, just depending on, to finalize all the results and such. So really staying on top of it if you do want to get your results back. And I did another study, that was in Baltimore, and then I did another study in South Carolina, and that was when I was younger, because I'm infantile onset, so I did it when I was about 14. And it was a natural history study, and you did like a 5-minute walk, and it was how quickly can you get up from a chair, and they did some cognitive tests about memory function. So they really were just exploring all areas. They had me do some basic algebra problems and such, so really just trying to cover all their grounds. But I would ultimately say, if you see a doctor regularly, any of the ones that are here in the room today, just ask them when you go to get your annual checkup. If you do, I highly encourage that you get checked up annually. Ask them if there's anything going on that you can help them help you, type of thing. So when I go to Dr. Catherine Wagner's every year, she usually asks for a couple of extra blood samples, and I gladly give that to her because they're already taking blood, so what's another couple? And so it's really just anything. If you've ever done muscle biopsies as well, that's easy to do, a little bit more surgically invasive. But really just, if you don't want to volunteer, if you don't want to raise money, you can give your body. So highly encourage it.
My name is Jim Fox. I live in north of Seattle, but I grew up in Maryland, and I happened to be back there working with my family estate. And somehow, I can't remember what got me started, but I wound up with Johns Hopkins, Dr. Catherine Wagner, and volunteered for a MRI study. And so I said, sure, great, I'd love to do it. And so I've been doing this for several years, I think 2 or 3 years, and it's basically go in every 6 months or so, lay in well, first we do a questionnaire, which just picks up some information about how I assess myself, and then we do a few strength test studies with a dynamometer. The researcher pulls against my hand and I pull back, and that gives a mechanical number. Actually, that was an improvement that came along during the trial. to actually use a dynamometer instead of just the 1 to 5 test. It's, 1 is you can lift against gravity. I don't know what 5 is. You can pull the tester away. So, but I have kind of followed the evolution of this test, and it's basically a test to use MRIs to actually let the MRI machine and the computer get a quantitative measurement of the different types of flesh between one area and another. And they have voxels. Instead of pixels, it's voxels, little cubical areas that are defined by the operator. And the computer, the heavy molecules, the magnet pulls them over, and then the heavy molecules snap back slower than the light molecules, which snap back faster. And it puts out a radio frequency pulse, and the antennas can detect exactly where that is. And so once you've got that, the computer has that data, then you have the ability to calculate, oh, it's changed from last year to this year 1.8%, instead of just a radiologist looking at the x-ray and saying, oh, it seems a little smaller, a little bigger. Now you've got some really good data. And so as an engineer, I really enjoy working on this trial. It's really good, hard engineering or quantitative data. And it's being developed, I'm told, that if and when or as we get cures, you'll do a test, take the cure for a year, do a test, and we'll have some data as to whether did it go up, did it go down, what happened. And so to me, it's just a wonderful chance for me to do something. This is my legacy. I'm leaving behind these MRIs, 2 or 3 years of MRIs that could be researched by some researcher 5 years from now, or 20 years from now, or some meta-researcher that could compare different tests and such. So I would highly encourage, we need volunteers, as we've seen today with the various speakers. Without volunteers, there's no raw data. And so I would also suggest, you've seen the hassle, the review process. All of these research projects are reviewed and reviewed and reviewed for funding and for approval. There's also very strong powers for volunteers for the test must be told exactly what's going to go on, very detailed, and then you've got all this review. So it's an important test by the time it gets funding. You will have very good information about what you're going to contribute or not. I contributed a couple of biopsies out of my bicep. Dr. Wagner took the biopsies. And then laying there in an MRI machine, I love it. They say, what kind of music do you want? 2001, Space Odyssey. I love it. I'm off on a trip. It's a 20-minute, I don't know. I just lay there. So then there is the physical test where you run down the hall and back, stumble down the hall and back. How far can you go in 2 minutes or something? How fast can you go up 4 stairs and down 4 stairs? What's the other? How fast to get out of a chair, go around the cone and back down into the chair. And it's a challenge and it's fun. And I would have one request to my researchers. I'd like to see the results. I think if they would give us citations or something, some way to get feedback from the report. I'd love to see what the answers or what the report is, and I think I'm going to have to start asking for them a little harder. So that's most of my comments. I'm certainly open for questions, but I would encourage anybody to volunteer. If you see a trial or something, go ahead and volunteer.
So are there any questions from people who are thinking about volunteering for a study and what's involved?
So I have more of a comment than a question. Well, first, I think an answer. My wife is in the process of this test as well. So 2 years ago, my son was diagnosed, and part of the process, they tested myself and my wife, who's also positive but asymptomatic. So we didn't know what to do. And this was something that we felt was a powerful way that we could do something. We felt helpless to help the cause. And to answer your question on the results, what they told her is they don't want to give you the results till you're done, because they don't want to have any influence of, you know, are you getting better, are you getting worse, that type of thing. So you'll get them eventually, but you may have to reach out. But also, too, they pay up to $500 for travel expenses. It's something we debated on whether she should do. Just, you know, it's, you know, a 2-year commitment. You're going back and forth. But I think next week or 2 weeks will be her third time out, a year into it. And we're so happy she did it. I'd encourage anybody to do it. We feel like we're doing something. She's doing something. And thank you guys for what you're doing.
Hi, I'm Lori from LA, and I am also participating in that whole body MRI study over at Johns Hopkins. And I really do encourage, I know they are looking for additional people to participate. The $500 certainly helps if you plan ahead. And it's not hard to do. It's just not hard, and it's easy. It's an easy way to contribute to the research and to our futures.
Thanks so much. I wanted to mention, I think in many of these studies, sometimes older patients might be more motivated and younger patients may be less affected. They may not feel like there's a lot to contribute. And obviously they're very busy with their lives, but I know with the whole body MRI study, they specifically were trying to get more younger people. And that's really important because that gives insight into the early stages of how FSHD develops. And this is ideally when we have a drug, you're going to want to treat as young as you can. You want to treat before the disease has taken a big toll on your muscles. So for the younger people or those of you who have, you know, younger family members, I think that's a really important message to share with them. Other questions?
I just wanted to add that when I went out back home to Washington State, I heard about a trial there, and it was an MRI study. I said, oh, cool, I'll volunteer for that. And it's the same study at a different research site. So it's about 2 years later. So in a sense, I've been helping them develop the study based on what I've learned at Johns Hopkins. And we're doing the same study there. So you can be parts of 2 different studies, I suppose.
Okay. Well, thank you so very much, Dr. Statland, Carden, Jim.
you.